So we are now on the last module for the midterm. So we have first, the slope of a line tangent to a function at a point. So yan. Okay, so our goal is to find a way to exactly determining the slope of the line which is tangent to a function at a point in a way which does not require us to have the graph of the function. So kumbaga, our goal today is to find a way wherein we can find the slope of a line or tangent that does not require us to graph. Kumbaga, magko-compute lang tayo. So let's start with the problem of finding the slope of the line L. So this is the line L here, which is tangent to the function x squared. So ito. So if we say tangent, based on sa quiz nyo, tangent is a line that touches the curve at only one point. So dito lang siya nag-touch. Only one point lang yung na-touch niya sa curve. Okay? So instead, here we could estimate the slope of L from the graph, but we won't. So hindi natin siya i-estimate. Instead, we can see that the line through 2, 4, this one here, this point, and 3, 9, on the graph of f is an approximation of the slope of the tangent line. And we can calculate that slope exactly. So if we can still remember the formula for the slope, that is change in y over change in x, or delta y over delta x. So that is y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. Yan. So this is our point 1. This is our point 2. So this is our y sub 2, so 9, yan. Minus y sub 1, which is 4, all over our x sub 2, which is 3 dito. Minus kay x sub 1, which is 2. So 9 minus 4, that's 5. All over 3 minus 2, that's 1. So 5 over 1, the answer is still 5. But here, this slope na 5 is only an estimate of the slope of the tangent line and not a very good estimate because it's too big. So we can get a better estimate by picking a second point on the graph of f, which is closer to 2, 4. So we can have any points na closer dito kay 2, 4. It could be here or dito sa right niya or nasa left niya. So pwedeng ganyan. So dito sa figure natin, figure 2. So this is instead of having 3, 9, this one here. So ito yung kinuha again, another point. So closer the 2, 2, 4. So 2.5 and 6.25. So yan. So if we try to solve for the slope, so here we have 6.25. So 6.25 minus 4 all over 2.5 minus 2. So yan, 2.5 minus 2. So 6.25 minus 4, that is 2.25 over 0.5. So that is 4.5. So now this is a better estimate, but still an approximation. So we can continue picking points closer and closer to 2, 4. So we can pick here. Yan, pwede din dito sa right side or nasa left side. So by picking closer and closer points to 2, 4, and then calculating the slopes of the lines through each of these points at the point 2, 4, so we can have this. Okay, so kumbaga, you can pick 1.5 and 2.25, 1.9 and 3.61, 1.19 and 3.9601. So itong mga nandito, nasa left siya ni 2, 4. And then ito naman nandito, nasa right ni 2, 4. Okay, so if you are to compute the slopes using this, so ito yung mga sagot nila. So now, upon observing here, dito sa mga answers ng slopes at saka dito kay x, okay, the only thing special about the x values we pick is that they are numbers which are close and very close to x equals to 2. So this one is closer to 2, here is also, ito si 3 close, and here closer to 2. So someone else might have picked other nearby values for x. As the points you pick get closer and closer to the point 2, 4 on the graph of y equals to x squared, the slopes of the lines through the points and 2, 4 are better approximations of the slope and of the tangent line. And these slopes are getting closer to 4. So yan. So dito na laman natin or nakita natin, observe natin na yung mga x natin dito, they are closer and close to 2. And then dito naman sa slopes naman, upon solving, so by the time na yung value ni x dito is very close to 2, yung sagot naman ni slope is approaching to 4. So kumbaga, the estimate of the slope is 4. Yan. So we have practice problem here. So again, itong practice problem na to, you can try to answer this one and then check your answer using the answer key na nasa baba. So here we can bypass much of the calculating by not picking the points one at a time. So we can have the calculations diretso. Yung hindi ba try and try. So let's look at general point near 2, 4. So define x equals to 2 plus h. For example, our x is 2 plus h. This one here. So here, itong si h is the increment. So if we say increment, that's the change from 2 to x. So if h is small, then x equals to 2 plus h is close to 2. So if our h is, for example, 0.009, so 2 plus 0.009, that is 2.009. So that is still close to 2. And the point 2 plus h and f of 2 plus h is equal to this one. 2 plus h and then 2 plus h squared. So bakit ganyan? Kasi we have this function. Ito yung function natin, x squared. So given here, this is our x, 2 plus h. So magiging 2 plus h squared yan siya. So yan dyan. So this is also close to 2, 4. Bakit kaya? So kung h is very small, so gaya ng sabi ko kanina, so 2 plus a value of h, that is close to 2. And then dito naman, 2 plus any value of h, and then if you square that one, that is still close to 4. Kasi nga, di ba, ang square ng 2 is 4. So the slope m of the line through the points 2, 4 and 2 plus h squared is a good approximation of the slope of the tangent line at the point 2, 4. So now we have this formula, this slope. We have increment of y over increment of x is equal to, so using these points here, this is our point 1, here is our point 2. So this is our y sub 2, 2 plus h squared minus y sub 1, which is 4, all over x sub 2, 2 plus h minus x sub 1, which is 2. And then square this binomial, you'll get 4 plus 4h plus h squared minus 4 all over. H na lang natira dito kasi nga 2 minus 2, that's 0. So h na lang natira. Dito naman, 4 minus 4, that's 0. So ang natira is 4h plus h squared na lang all over h. So dito sa ating numerator, we can factor out h. So yan. Then natira sa loob, 4 plus h. And then h over h, that is 1. So ang natira is 4 plus h. So here, if h is very small, then m equals to 4 plus h is a very good approximation of the slope of the tangent line. And m equals to 4 plus h is very close to the value 4. So kumbaga kahit anong value yan ni h, basta very small yung value na, for example, for h is 0.0013. So still that is very close to 4. So we can now get the approximation that the slope of this line here is really 4 or closer to 4. The value m equals to 4 plus h is called the slope of the second line through the 2 points 2, 4 and 2 plus h squared. So we have encountered again this word, second line. So if we say second line, this is a line wherein it touches 2 points of the graph. So dito, sa figure 3, 2 points yung na-touch ni line na nasa black na ink. So second line yan. Pero kung 1 point lang sa graph yung na-touch niya, that is a tangent line. So the limiting value 4 of m equals to 4 plus h, as h gets smaller and smaller, is called the slope of the tangent line to the graph of f at 2, 4. Yan. So ganun pala ang pagkuha or pag-approximate ng slope of tangent line and second line. So we have here, example. Find the slope of the line tangent to f of x equals to x squared at the point 1, 1 by evaluating the slope of the second line through 1, 1 and 1 plus h f of 1 plus h. And then determining what happens as h gets very small. So ito yung figure natin. Yan. So the slope of the second line through the points 1, 1 and this one, 1 plus h f of 1 plus h is. So this is our y sub 2. F of 1 plus h minus our y sub 1, which is 1. All over our x sub 2, our x sub 2 is 1 plus h minus our x sub 1, which is 1. So here, our function is still x squared. So kaya atong f of 1 plus h natin, that becomes 1 plus h squared minus 1. And then 1 minus 1, that's 0. So h na lang natira dito. Square this. So you'll get 1 plus 2h plus h squared minus 1. So 1 minus 1, that's 0. So 2h plus h squared na lang natira all over h. And then factor out h dito. Ang natira na lang is 2 plus h sa loob. So h over h, that is 1. So we have our final answer as 2 plus h. So what happens now as h gets very small? So as h gets very small, the value of m or the slope approaches the value of 2. So the slope of tangent line at the point 1, 1. So yan. So ganun lang siya ka simple. Okay, so we have another practice problem here. Next is we have, for example, a falling tomato. Okay, suppose we drop a tomato from the top of a 100-foot building. So dito sa figure 5 and time its fall. Okay? So ito na yung record mo na time. So nag-start ka, so nasa 100 feet yung height mo kasi nasa 100-foot building ka. And then after 0.5 seconds, 96 feet na lang yung height ng tomato. And then after 1 second, 84 na lang, 1.5, 64. After 2 seconds, 36. And then nag-drop na talaga siya sa ground after 2.5 seconds. So some questions are easy to answer directly from the table. Okay. How long did it take for the tomato and to drop 100 feet? Okay, so dito sa record mo, so that's 2.5. So yeah, 2.5 seconds. How far did the tomato fall during the first second? So during the first second, that's 84. So 100 minus 84, that's 16. So 16 feet yung na-travel niya. How far did the tomato fall during the last second? So yung last second natin is dito. Okay? So that is 100 minus 36. That is 64. Or you can just 64 minus 0. That's 64 feet. Then how far did the tomato fall between t equals to 0.5 and t equals to 1? So sa 0.5, that's 96. Sa 1 naman is 84. So 96 minus 84, that is 12 feet. Yan. So some other questions require a little calculation. So what was the average velocity of the tomato during its fall? So the average velocity, so ito yung nakuha natin. And meron ding, nakita nyo din to sa ating quiz of velocity. So we have distance fallen over the total time. So yung distance fallen niya, so that is the height of the building. So that is 100 feet. So yan. So negative siya, it's because pababa siya. So negative 100 feet all over the total time is 2.5. So yan, 2.5 seconds. So if you will solve this, then you'll get negative 40 feet per second. So that is the average velocity. Now, what was the average velocity between t equals to 1 and t equals to 2 seconds? So the average velocity is, so you need to find yung distance after 1 second, after 2 seconds. So dito sa first na we have, sa first second we have 100 minus 84. So that's 36. And then after 2 seconds, you can have here, So nagbaliktad lang sila 100 minus 64. Yan. So 84. And then all over 2 seconds minus 1 second. So ito yung distance nila again. So after 1 second, 84. After 2 seconds, 36. So yan. 36 minus 84 over 2 minus 1. So 36 minus 84, that's 48 all over 1 second. So therefore, we have negative 48 feet per second. Yung average velocity niya between 1 and 2 seconds. So some questions are more difficult. So how fast was the tomato falling 1 second after it was dropped? So kung 1 second after it was dropped, this question is significantly different from the previous two questions. So hindi siya pareho dito. Okay? So here we want the instantaneous velocity. So ang instantaneous velocity, that is a velocity at an instant in time. Unfortunately, the tomato is not equipped with a speedometer, so we will have to give an approximate answer. So one crude examination of the instantaneous velocity after 1 second is simply the average velocity during the entire fall. So the entire fall, dito nakuha natin is the negative 40 feet per second. But the tomato fell slowly at the beginning and rapidly near the end. So negative 40 feet per second estimate may or may not be a good answer. So kung babalik tayo dito, so nag-start siya. So medyo mahina pa yung pag-fall niya, pero as the time goes by, so yan, medyo mabilis na yung pag-fall niya. Kasi nga mataas na yung, or medyo malayo na yung distance ng kanyang na-travel. So yan. So we can get a better approximation of the instantaneous velocity at t equals to 1 by calculating the average velocities over a short time interval near t equals to 1. So we can have the average velocity between t equals to 0.5 and t equals to 1. So 0.5 and 1. So 0.5 at saka 1. So 0.5 at saka 1. 96 minus 84, that is 12. So kaya may 12 tayo dito. So negative all over. So 0.5 minus 1, that is 0.5. Or 1 minus 0.5, that is 0.5. So you'll get negative 24 feet per second. And the average velocity naman between 1 and 1.5. So 1 and 1.5. So that is 64 minus 84. That is negative 20 feet all over 0.5. So negative 20 over 0.5. That is negative 40. So now we can be reasonably sure that the instantaneous velocity is between negative 24 feet per second and negative 40 feet per second. So yan, between negative 24 and negative 40 yung instantaneous velocity. So yung ginawa natin is we have computed the average velocities closer to 1. So 0.5 and 1, and then 1 and 1.5. So in general, the shorter the time interval over which we calculate the average velocity, the better the average velocity will approximate the instantaneous velocity. So the average velocity over a time interval is this one, delta position over delta time, which is the slope of the second line. So ito siya, second line. Through 2 points on the graph of height versus time. So the instantaneous velocity at a particular time and height is the slope of the tangent line naman to the graph at the point given by that time and height. So kumbaga, ito siya. If we say average velocity, that is slope of the second line through 2 points. Kung instantaneous velocity naman, that is slope of the tangent line to the graph. So again, if we say second line, 2 points yung na-touch niya. And then if we say tangent line, isang point lang sa graph yung na-touch niya. So yan. So kung 2 points, that's for the second line, slope ni second line. Kung instantaneous velocity, that's the slope of the tangent line. So we have another practice problem here. Next, we have growing bacteria. Suppose we set up a machine to count the number of bacteria growing on a Petri plate. So dito, ito na yung graph. At first, there are few bacteria, so the population grows slowly. Then there are more bacteria to divide, so the population grows more. quickly. Kasi nga yung pag-grow nito is exponential. Later, there are more bacteria and less room and nutrients available. Kasi masyado na silang marami for the expanding population. So, the population grows slowly again. Yan. So, nag-start siya dito slow and then marami na masyado and then it became, balik naman siya slower. Okay, yan. Finally, the bacteria have used up most of the nutrients and the population declines as bacteria die. So, kaya ganito yung kanyang graph. So, the population graph can be used to answer a number of questions. So, what is a bacteria population at time t equals to 3 days? So, here, nasa x-axis natin yung number of days. Dito naman sa y-axis natin is the number of bacteria in thousands. So, this is 1,000, 2,000, 3,000, 4,000, 5,000. So, after 3 days daw, so 1, 2, 3, after 3 days, so nandito siya. So, half ng 1,000. So, that is 500. And then, what is a population increment from t equals to 3 to t equals to 10 days? So, tignan natin yung sa 10 days kasi alam natin yung sa 3 days is 500. Kung sa 10 days naman, so dito siya. So, this is here, 4,500. So, 4,500 minus 500 na nasa after 3 days. So, you'll get 4,000 bacteria. About 4,000 bacteria. Next, what is the rate of population growth from t equals to 3 and t equals to 10 days? So, yan. So, that is now same kanina sa velocity. So, now we are to find the average change in population. So, that is the increment in population over increment of time. So, we have learned na between 3 days and 10 days, yung population increment is 4,000. And then for that time, t minus 3, that's 7. 10 minus 3, that's 7. So, 4,000 over 7, that is 570 bacteria a day. So, now this is the slope of the second line through the 2 points. Na 3,000, 3 and then 500 and then 10 na 4,500. Next is what is the rate of population growth on the third day at t equals to 3. So here we are to find the instantaneous rate of the population change. So kumbaga tangent line. Okay? So the slope of the line which is tangent to the population curve at 3 and then 500. So dito siya 3 and then 500. If this question line approximately tangent to the curve at 3, 500 and pick 2 points near the ends of the tangent line segment, same sa first na topic kanina or first section kanina. So it could be to the right or to the left. So we can estimate the instantaneous rate of population growth is approximately 320 bacteria per day. So you can choose here, you can choose 4 days dito and then 1,000. You can choose that one and then you can choose another point closer to 3 and 500. Then you can observe there na it is approaching to 320 bacteria per day. So as a whole, the average population growth rate is this one. Increment of population over increment of time or delta population over delta time. So that is the slope of the second line through 2 points. Kung instantaneous naman, that's the slope of the line tangent to the graph. So we have another practice problem here. So to wrap up, the tangent line problem, the instantaneous velocity problem, and the instantaneous growth rate problem are all similar. So same lang sila, no? Kasi nga ang ginagamit kay instantaneous velocity at saka ka instantaneous growth rate problem is the tangent line problem. In each problem, we wanted to know how rapidly something was changing at an instant in time. And each problem turned out to be finding the slope of a tangent line. Yan, the approach in each problem was also the same. So find the approximate solution and then examine what happened to the approximate solution over shorter and shorter intervals. So we will often use this approach of finding a limiting value, but before we can use it effectively, we need to describe the concept of a limit with more precision. So kumbaga yung mga na-learn natin today, that's the concept of limit. So kumbaga kung saan siya approaching ang mga answers, anong number siya approaching. Yan. So now we have here some of the problems and then some of the practice problems. Yan.